In this video, we're going to look at strings. Now, this is a particular data type in Python that gives us a lot of power. Now, remember, whenever we input data from the user, we're given a string. And there are several utilities we can use, such as int, float, or something else like that, where we can transform the data type from one to another. Now, Python takes care of all the difficult portions of it for us. But one of the things that we're going to have to look at is how this actually happens using strings. Now, strings are quite powerful as they have a lot of different methods involved. So keeping track of it is going to be important. So you may have to pause this video, rewind it several times, just so you can get every single part that's going to be in here. Now, every single lab that you're going to do is going to take some sort of input and some sort of output. And in that case, you know you're going to get strings. Now, some of these are easy enough where you can just transform them into integers directly. However, remember what Python does. So let me give you a example here. So say I want like something in my input as like a calculator, 5 times 3. Now if I do that, we're given an entire string 5 space star space 3. Now what would happen if I want to use those inputs as 3 different inputs? The left number, the operator, and then the right number. Now, what we'd have to do in this case is we would have to do something naively. We would do something like this. We'd say enter left number, enter right operator, and then finally enter right number. So in this case, now we have all 3 different inputs in 3 different variables. So I can do enter left number 5 times 3, and it gives us 5 times 3. The problem with that is it's very awkward. And plus we want to be able to use Python in a way where we can actually set or use one line of input. Now this is going to be the case whenever we read from files. So you have to read the labs very carefully to see if it's all on one line, if it spans multiple lines and things like that. So input in Python will grab one line and return it to you as a string. So what can we do? So let's take a look at the learning objectives for strings, and then we'll see how we can actually solve this problem using string utilities. So the first thing we're doing is we're understanding what the string data type is. We've covered that a little bit in types and variables. Be able to concatenate strings, we've done that as well, where we added 2 strings together using the plus operator. Be able to convert a string into another data type, such as an int float, we've done that before. Be able to use string functions to format a string, we'll take a look at those. Be able to use slices to extract portions of a string, we'll take a look at that. Be able to find data within a string, so that's how you find certain needles that we call them inside of a larger haystack. Okay, is this present inside the string? Be able to create a string from a list using join, be able to replace patterns in a string, be able to strip white space on the leading or trailing edges of a string. So a lot of that has verbiage that you're probably not familiar with, like trailing white space and things like that. When we say white space, we mean spaces, tabs, enters, that sort of stuff. So the new line character \n, the tab \t, and then a space, just a space. Those are called white space. And a lot of times, based on if I type 5 enter, some languages will give us 5 with the new line character. Some will just give us the 5. So it's important that we know what we're given, especially inside of a file. Because if we have that new line character and we try to convert it into an integer, it's not going to work. So we want just integer data. We want stuff like that. So let's take a look at how we can actually solve this issue using string utilities. One of the powerful things that we can do in strings is what's called splitting a string. So let's take a look at what that means. Let's call my input okay, so if we print this, we can once again just validate that yes, that's not what I want. That yes, we get 5 times 3. So 5 times 3 is going to give me a string 5 space star space 3. Now what I want to do is I want to break that up into 3 different fields. So we're going to use something called split. Whenever we split, the string will split the string based on a delimiter. Now, generally the delimiter is a space, which it is here, but it can be anything that we specified. For example, if I have a date, something like 5-30-20 or something like 2020 or something like that, then I could use the delimiter as a hyphen. And in that case, I'm going to get 5, 30, and 2020 as 3 different elements of a list. So let's take a look at how split's going to work. It doesn't change the string. It just looks at the string, delimits it, and then gives us back a list. Now that list is going to be a list of strings. So we'll take this step by step. So the first thing is we have input. Hopefully everybody can see the issue here. We have one line of input, which is 5 star 3. Instead, I want 3 variables, one with the 5, one with the star, one with the 3. That way there, I can use mathematical operations. I can use an if statement to see whether it's going to multiplication, addition, subtraction, that sort of stuff. So let's split this. Let's call this ops equals a dot split. Now we can specify the delimiter, but if we don't specify a delimiter, it's going to be a space. But to make it readable, I always put the delimiter in there. We're saying that it's a space in this case. So now I'm going to print a, and then I'm going to print ops to see what we get. So we do 5. I don't like that it does that. 5 times 3. Notice we get 5 times 3. That's the original string. But then when we split it, we get 5 as a string. That's element 0 inside the list. We get star in the string. That's element 1. And then we get 3. So as you can see, we've split the string and we've gotten all 3 portions. So once again, we're almost there. But we want the 5 and the 3 to be integers. So I could easily do something like this. Ops 0 equals int ops 0. Now there's better ways to do this, but we're not going to cover those right now because all we're trying to do is get this into a format that we can work with. Now remember, ops 1 is going to be the star, so ops 2 is going to be the other part. So actually let's call this the left operand and let's call this the right operand. Okay, and then we'll call the ops 1. Okay, so now what we can do is we can take a look at the operand to see what operation we're going to perform. So if the op is a star, we do result equals left times right. Else if the operand is equal a plus, we do result equals left plus right. Else if it's dash, result equals left minus right. And then we'll print okay, and then the last thing we'll do is just say else result equals left. Okay. All right, so we have to have result in here somewhere because we're using result here. So let's go ahead and run this. Now what we're going to do is we're going to do 5 times 3. And when we do that, notice we get the value 15. Well, how do we get the value 15? Well, notice what happens is whenever we split this, we're going to get 3 pieces of information. We split here, so Python's going to split between the 5 and the star. Now look what happens if we do not provide the space. If we do 5 times 3 like this. Notice it does not work because the split requires a delimiter. The delimiter in this case is going to be a space. Now it's going to take additional logic if you wanted to handle this case, but that's not the point of this lecture right here. So split is going to be widely used in most of your labs that you're doing here, whether you're reading from input like here or whether you're reading from a file. Now generally, unless it's a binary file, all text files, if you read a line or if you read some amount of text from it, you're going to get back a string. So using these utilities is going to be extraordinarily important. So you can see split gives us to it, but remember, once again, we are given a list of strings. So if you want those in a different format, you have to do something like this where you do the typecasting that we've done before. Now this is actually more than typecasting, it actually converts it from a string into an integer. So split is one way that we can do something like that. Another thing is if we want to add strings, so say like string 1, string 2, now remember, plus operator means one thing for floats and integers and one thing for strings. So I'm going to call my result st1 plus st2. So this is one way we can do it. And if I do that, you're going to see that we get hello space world. Why? Because hello is st1, plus is called the concatenation operator if we're using it in the contents of strings. Now strings, unlike integers where 1 plus 2 is equal to 3, a string is just tacking them on together like this. So st1 comes first, followed by the plus, which is followed by a space, and then that's where this space is coming from right here in between hello and world. And st2 is world. So you can see we can add a literal like the space, or we can add a variable that's a string like we did in st1. And we could also convert any other type of data. Let's say we have 5 here. I can convert all data types into a string by using str. And so notice we get hello world 5. That's because this is an integer right here. Now, if we were to put that on the end, notice we get, hey, that's an integer. We can't do anything with that. So you have to you have to convert it using str, and now that 5 is converted into a string. So that's concatenation. There's another way we can do it by using what is called formatting. Now, formatting is a special string function in which we can do something like st1, let's see, so what we do is the very first thing is we provide what's known as a format string. Now, the format string is how do you want this to be presented? So actually, let's bring that back. Okay, so in this case, these little the squiggly braces are known as formatting characters. They're not going to be actually present in the string if we use .format. So you can see the left-hand side of the dot is a string. So format is a member of the string class. And so what we're going to do is in format, it's expecting 2 different variables because I have those 2 little squiggly braces in there. Those squiggly braces aren't going to be printed or developed into the string. Instead, they're going to be replaced. They're going to be substituted by st1 and st2 respectively. So we print A, and notice we get hello space world. So format's a lot more powerful, but you have to understand how these are going to work. So for example, let's say I had st3 equals 7.4999999, something like that. Say I want that to be inside of here, but I don't want it to be 7.499. I only want 1 decimal point of precision. So what you have to do is you have to do what's called a specifier. Now, there's a list of specifiers within the documentation as well as in the textbook. I'm not going to go over those here, but just the specifier starts with a colon. So this is going to be our specifier. We can also specify whether it's going to be left justified, centered, or right justified, that sort of stuff. Once again, that's in the part of the textbook as well as the documentation. But what I'm going to do here is I'm going to do 2f. And let's take a look at what that gives us. It gives me 7.50. Notice that it rounded. So what are we talking about here? Everything to the right of the colon is what's called the format specifier. In this case, what I want is 2 decimal points of precision. Well, this dot tells Python that we're now talking about everything to the right of the decimal. How many decimal digits do we want to the right of it? And that's where this 0.5 comes from. Notice there are 2 digits to the right of the decimal place because I specified this too. F stands for float. However, it also stands for fixed floating point. So in fixed versus scientific notation. So there are 2 different ways we can do that. We can do it in scientific notation or fixed note notation. So this is fixed note notation that we always look at. So whenever we specify 2 digits of precision in fixed point, it's telling you how many digits do we want to the right of the decimal place. If we did that in scientific notation, it's telling you how many total digits do you want. So for example, if I did 2 at scientific notation, I get 7.5. So that's essentially what we're going to use. .format is going to help you put a string together if you wanted to, or it's going to help you specify the precision, justification, whether I want something left justified, make a nice table, things like that. Once again, all that's inside of that string documentation. The references are at the bottom of the lecture notes. And you can look at that as well as the textbooks to see what all the different specifiers are. There's a lot of them, but really the only ones that you're going to be using are really the float for decimal precision and maybe the justification left, right, center justifications. So now that we've taken a look at that, let's take a look at another thing inside of strings, which is called a slice. Now, a slice is a way where we can get a portion of a string. So for example, we have hello and then we have world. So let's take a look at hello space world like this. Now a slice uses the square brackets much like we do with a list. Now remember, in a list, if I did a sub 0, that's going to give me the first element of a list. Now if you think of a string as a list of characters, it kind of makes sense what we're doing with these slices. So let's say a is equal to st1 sub 0, and let's print it. Notice I just get capital H, which is the first portion. So that's the first character that we're going to get. If I use st1, it's going to be the second character, which is lowercase e. Now in a slice, so this is getting 1 character. However, we can get multiple characters at once by using what is called the slice. Now the slice looks a little bit different than what we've done in list. Now you can use these slices in list, but I don't think we usually do those in list. You can if you want, just to pare down a list or expand it however you see fit. So what I'm going to do is there's several different ways we can specify a slice. So a slice is a colon. and you specify the starting point in the beginning and the ending point in the end. So just like that range function that we looked at under loops, a slice has the starting point, which is inclusive, and the ending point, which is exclusive. So in this case, we're going to get 0 and 1. So 0 is the capital H, that's the first element in there, and E is the lowercase, or is the index 1. So notice that we didn't get index 2. So starting point is inclusive, ending point is exclusive. And that's important to know because if I wanted the entire thing, HELLO, we know 0, 1, 2, 3, 4. So if I did 0 through 4, because those are indices that I want, we only get hell. We don't get the whole thing. So what we have to do is we actually have to add 1 to get hello. Now there's a shorthand. If you want to start by 0, you can just leave it off. This is equivalent to 0:5. As you can see, it gives us the exact same result. So if we leave a number off it on the left-hand side of it, it tells Python we want to start, that our position is going to be at the starting point. Same thing about the ending point. If I do something like 2 and I don't put the position at the right-hand side of the column, that tells Python to go to the end of the string. So as you can see, we're going to get LLO space world. So that's what this is telling us. So notice that this is inclusive. So it says inclusively start at index 2. So H is index 1, H is index 0, E is index 1, and the L is index 2. So that's where we're going to start printing from. So that's how we get this string. Now, another important thing is we can actually specify negative numbers. So notice everything that we've done from now with positive numbers starts with the left-hand side of the string, just like we read left to right. However, using negative numbers, we can go right to left. So for example, if I did -1, we're going to get D, which is this D right here. So what it's saying is it's the length -1. So essentially, if you did length of st1 -1, you get the exact same thing. But because we know what the length is, we can just leave off the length. So for example, if I want L and D, I can do -2 all the way to the end. So that's telling me the starting point, and it's saying go to the right and give me everything else from it. So for example, if we just want world, we'd have to back it up 1, 2, 3, 4, 5. So we back it up 5 and we print everything else from there, and we're given just world. So that's important because that allows us to actually split strings apart. We can move things around. So for example, if I wanted world hello. So we know that A is now going to contain world. And if we want hello, we do st1 all the way up from 0, 1, 2, 3, 4, 5. And then what I can do is I can do B plus A. Whoops, we need a space. Let's just do comma. There we go. So now we get hello world. If we did A plus B, we would get world hello. So as you can see, I'm slicing and dicing this string so that I can hold on to chunks of the string. So we could use this in conjunction with what's known as the find operation. So in this case, we can actually find where the space is located by saying the position, POS, is st1.find. And what I want to do is I want to find where the space is. So the way that find works is it's going to search through the string and look for from left to right, and it's going to look for the very first occasion of your needle here. In this case, I'm saying a space. Now, if we want to start from right to left, we do what's called a reverse find, which is rfind. But in this case, we just want to move left to right, so I'm just going to put find here. Now, the way find works is it's going to return us the index where this key was found. Now, if this key was something like world, it's going to tell us where the W in world was found. Otherwise, if that key was not able to be found, it's going to return us the index -1. So in this case, let's go ahead and print position, and let's see what we get here. Actually, I'm going to leave this. Okay, so the position is 6. So world starts at 6. Let's see if that's correct. So let me get my pen out here. So H is 0, ELLO space world, okay? 0, 1, 2, 3, 4, 5, 6. So indeed, it gave us the correct answer. So let's see what happens if we give it a needle that is not found. Let's say John, okay? Now that the needle wasn't found, it returns us the value -1. So that's something we can pop into an if statement to see, okay, is it -1? If it is -1, that tells us the needle could not be found in the string that we're searching through. So in this case, John was not able to be found, so it returns the value -1. But let's go back to our original one. Notice in this case, we knew that hello was 5 characters. We knew that world was 5 characters as well. And so that made our lives a little bit easier. But what if we had two things separated by spaces and I want to grab the first thing and the last thing? Now notice we could use split, but let's see how to actually write split, or how they did split, by using find instead. So now what we want to do is we want to find where the space belongs. Okay, when I do that, it's telling us the space is at index 5, which if we look down here, we can see that yes, indeed, index 5 is where the space is located. So that's essentially what I want here. So A is going to be negative position, and this is going to be pulse right here. So let's go ahead and say John Smith. Okay, so John is now 4 characters, whereas Smith is 5 characters. So let's see if this works. Okay, notice we get myth John. Why is that the case? Well, because what we're doing with st1.find is, remember, the negative position was because that world was 5 characters long. The positive position was because that hello was 5 characters long. Well, because I've done that, we're assuming that the position, which is 4, is going to be the size of both. That's why we get 4 characters here, 4 characters here. So how do we fix this? Well, number one, what we can do is we can use the position as a starting and ending point. We know that B is working properly, but we can do something like this. So what we've done is Smith John. Now remember, what is this little space here for? Now remember, the position, the starting position, is inclusive. So because we're looking at index 5, we're looking at the space. And because I put the index 5 here, it's actually going to print the space followed by everything else. So what we actually need to do is position +1. And when I do that, notice we get Smith John. So that's essentially how the split is going to work. Is essentially what we do is we just keep finding where space is. We pop the first half into a list, we split the next half, pop it into a list until we're done with the string. Now remember what I said is we have what's called rfind, and let's say we had Smith Casey or something like that. Okay, so reverse find is going to go from the right to the left, whereas find is going from the left to the right. So let's take a look what this position is going to be in this case. Okay, so notice that our space is now at 10. So we said, let's erase that. There we go. So we have John Smith, and then this space is located at index 10. So why are we getting Casey John Smith? Well, remember, whenever we do position 1 with a colon, that says go to position, add 1, which is where the K is, and then go to the end of the string. So that's where Casey is coming from. A contains the value Casey. However, this right here is telling us start from the very beginning of the string, which is this portion, and go all the way up to, but not including index 10, which is John Smith. So that's why we're getting John Smith. So there you have it. That is how you can actually find information inside of a string. So to review, remember the position, it's going to find you, rfind will go from right to left and it will give you the index of the very first element that it finds that you put inside of here. So in this case, I put a space, so that's what it's finding. If we don't use rfind, it's going to go from left to right and it's going to give us the position. If the needle could not be found in the string, it's going to give us the value -1. So it's always important that we actually check the value to make sure that we got the value. Because -1 is a valid slice in here, it might give us something weird where all of a sudden the string is backwards and we don't understand why. And the reason is because the position that we're given could not be found, so we got the value -1. So let's talk about replacement. So replacement, so strings are what are known as immutable. That means every time I want to change a string, I actually have the old string and the new string as copies of each other. Unlike a list where I can modify each individual element of a list, I can't do that with a string. And so it seems like it's happening, but the way Python works, it can't do it. So for example, remember we said that a string is essentially a list of characters. So if I was to do st1 and pop in here an A instead, notice we get does not support item assignment. That's because this string is immutable. However, what if we want to replace something inside the string? So we don't actually have to replace each one of those characters inside the string because Python can do that for us. Now, let's see if I did John. So replace takes two parameters, the old and the new. So I'm going to say Todd. Okay. Now, notice that st1.replace is right here and that we're printing st1. Now, remember what I said is strings are immutable. So that's why we get John Smith Casey. It's as if nothing ever happened. The reason is because the replace is going to give you the new string. So we'll call it st2. Okay, so notice we get John Smith Casey, and then we get Todd Smith Casey. So replace will replace every single instance of that. So let's go John, John, John. And notice we get John, 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 Todd, Todd, Todd. Now we can specify a third parameter, which is the maximum count. So say we only want 2 Johns replaced. We do that, we get John, 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 Todd, Todd, John. So this right here is telling us we can have up to 2 different replacements. And because there are 3 Johns in there, only the first 2 Johns get replaced. So that's how replacement's going to work. So the important thing to know about replacement is we have to specify at least 2 parameters. If we specify 2 parameters, that means replace every single instance of John. It's also case sensitive. So John has to be capital John. If I have lowercase Johns, like this right here, it's not going to be replaced, as you can see right here. So it's case sensitive, so make sure that the cases are correct. If I specify the third parameter, that's saying the maximum number of replacements we're going to make. So in this case, since I specified 1, only 1 John is replaced with a Todd. And finally, whenever we do a replace, the old string still remains, and it's going to return to us the new string. So you have to capture the new string by setting it equal to string.replace. So let's talk about going the opposite direction. So we talked about how to split a string. So let's say A equals John David Smith or something like that. We'll call it names equals a.split. So in this case, we split them by spaces. And let's go ahead and print the names out just to show that we actually have John David Smith. Now, going from a string into a list, we can use split. However, going backwards, we have to use what's called join. And we actually have to specify what we want to join these with. So for example, what we're going to do is we're going to say result, we'll call R. And we have to specify a string that is going to join these. So for example, if I want to join these by dashes, I will do dash.join. And then in here, I give it the list that I want to join. So in this case, John David Smith is the list, which is called names. And then I'm going to print R and show you what it looks like. So notice that we have John David Smith, and now we have a string, John-David-Smith. And what happened is this dot join, what it did is it went through each element of the list and added it into a string. So it concatenated it. The manual way to do this would be do something like this. So let's say for name in names, let's call R a string like this. And then what we'd have to do is we'd have to say R plus equals name. And it looks something like that. But if we wanted dashes in between, we have to do this and then remove the final dash at the end. Whoops. There we go. So it looks something like this. Okay. As you can see, that's a much more difficult way to do it, but dot join does that as well. So say we wanted to get John David Smith back out. Well, as we know, what we're going to do is we're going to use, this is what we want to join with. That's what the string is. So now we're going to join with spaces. Let's say we want 10 spaces in between or something like that, 5 spaces. Dot join names. Okay, notice we get John, David, and Smith. So join's going to be powerful because we can take a list, we can join all the strings inside of a list and get it that way. Now, look what happens whenever we have 1, 2, 3, something like this. Okay, notice that it's expecting strings, but it was given integers. So this is a list of integers, and it's like, I have no idea how you want me to join these because they all have to be strings. So you have to be careful whenever you use join that you provided a list that has nothing but strings inside of it, or at least a slice that has nothing but strings inside of it. So for example, if I have John, David, and then Smith like this, Whenever we run it, notice it says item 3, expected string instance, int found. Well, what we can do here is we can take off the last 3, and now we're given John David Smith. So it doesn't matter that there are integers in the string, it's just that the slice that we give it, everything that's going to join has to be strings. So there you have it, that's how join works. Now there's a bunch of other functions. For example, so lower is almost like replace in that it keeps the old string with its capital John and then gives us lowercase John. So if we had this all in like John capital letters, it gives us John in lowercase letters. We also have something called capitalize, which will only capitalize the first letter and everything else will be lowercase. And then we have upper, which will uppercase everything inside there. So the important thing to know is that it gives you a new string. So if I did a.upper right here, and then I printed a, we're going to get the old string, not the new string. So we have to set something equal to it so that we can capture the new string. So in that case, we talked about all of these different functions in there. So once again, like I said, you might have to go back through the video and start looking at how these different things work. The important thing to know is that whenever we receive input, that input's coming to us as a string. And whenever we do one input, we're going to get the entire line of input. And so if everything is on one line, we're going to have to split that input based on spaces or whatever happens to be. And then what we'll have to do is dissect each element of the input. So we said we understand the string data type. So we looked at a whole bunch of different functions. We understand a string is just a sequence of characters. How do we manage these sequence of characters? Be able to concatenate strings. We saw how we can slice them. We can add them together. So unlike integers where we add 2 integers, we add the sum of those integers. With a string, we concatenate. If I have one string plus another string, it just pops them onto each other. Convert a string into another data type. We saw that with int and float and things like that. We can also convert an integer or a float into a string by putting it in str, open parentheses, close parentheses. Be able to string functions to format a string. Remember, those format specifiers are located at the bottom here under the references Python string. So make sure you take a look at that. Be able to use slices to extract portions of the string. Now, once again, we use slices as well as .find to give us the position where we need to slice. So remember, we had hello world. We use .find to give us the position of the space. And remember that the beginning, the starting point of a slice is inclusive, whereas the ending point of a slice is exclusive. And also remember that we can use negative numbers so that it goes from right to left instead of left to right. We use join. We looked at find to be able to find stuff inside there, be able to replace patterns, and be able to strip white space on the leading. So one thing about stripping white space is there's another function in here. So for example, if I had John, \n is a new line character, Smith, and we printed this, notice we get John on one line, Smith on the other line. So what if we wanted to, well, let's say we had leading and trailing white space, so spaces and things like that. So we get John with a tab, we get Smith, and a whole bunch of new lines. Now, the reason this is important is because if we read an entire file, like in this file right here, I can have a whole bunch of ending spaces, I can have a whole bunch of beginning spaces, that sort of stuff. And what we want to do instead is we want to make it all condensed so that whenever I read the first character, that is data. And whenever I read the last character, that is also data. And everything in between is data. So what we can do is we can use what's called a strip. Okay, now if we can specify the characters that we want to strip, so like \n, \t, that sort of stuff. But once again, strings are immutable. So it's going to strip off the trailing and leading white space and then return us the new string that doesn't have that in there. So notice that we had John Smith with tab spaces and all these new line characters, and then we got John Smith. So notice that this \n is still there because it only strips away leading, which is the \t in these spaces, and trailing, which are these \n's right here. So let's go ahead and take away that \n. Let's say s is equal to a and see what happens. So notice we get John Smith like that. And let's put some beginning. Okay, so begin is right here, John Smith, and notice all these new lines. So let's strip this and see what happens now. Okay, so now we have begin. Now these spaces are automatically added in by print whenever we do a comma. So there are no real spaces in there. So that means that there are no leading or trailing white space when it came to this by using strip. So strip is going to be important if we want, like I said, the very first character is data, the last character is data as well. However, remember, it doesn't touch anything in between. So if I have this new line character in between here, oops, that's a backslash, there we go. This new line character in between here, whenever I run it, that new line character is still there. And so what you'd have to do is you would actually have to search for a backslash n and replace them or something like that. So there you have it. That is Python strings. It's very powerful, but it's going to take some practice before you get it down what all these different functions do, what they are. So for example, if you're like, okay, I don't remember how to do this, well, that's why there's this video, there's all these reference material, as well as the lecture notes in the website. So there you have it. There's Python strings. Thanks for watching.